Thanks for inviting me, and we'll see about True Expert, but I've been working with this for quite some time, with speech for quite some time at least. I would ask you one thing, and you do not have to comply, of course, but if a couple of you or many would like to go beyond your borders and turn on your videos, it's a hell of a lot easier to actually give a presentation to people that exist than to people that doesn't. Talking into a void is something that no one should be forced to do, to be honest. Okay, I'm going to talk about speech and speech research. I'm going to try to tie it a little bit to artificial intelligence and to machine learning and to modeling. I will try to be a little bit provocative, a little bit more provocative than maybe I should be, but well, you have to bear with me. It's a way to get a discussion started. I should also say that it's my wife's 50th birthday today, but if this was the only Wednesday of the ones that I was invited to that was open at all, so I'm not going to take questions forever this afternoon. I will try to keep the talk to 45 minutes, and then I have 45 minutes for questions, maybe a few minutes more, but that's it. I'm sorry about that. I would really enjoy to take questions for any time and have a discussion, but I can't. All right. I'm Jens. I'm an associate professor at KTH in speech technology, or possibly in speech communication. I tend to forget. I think that I'm defined maybe by being pretty interdisciplinary. I have a graduate background in the humanities, as a linguist, a phonetician. But I've been at KTH since the late 90s, and my PhD and docent are both from KTH. Although one of them is in speech communication, which is a relatively soft field. I currently am the PI of a bunch of projects that are funded within humanities, technology, infrastructure, maybe something even that is funded from medical or societal funds. I'm also the director of a national research infrastructure, Språkbanken Tal, which is a part of Nationella Språkbanken. This is something that we're building up now. It's not really open for the public until January 22, so in a year. But we are running projects, rather a lot of them, to try to get resources in that we will then share. So speech resources, sorry about this will only happen once, and it was anticipated. I have to open the door for a delivery. That's it. Now I'll turn my phone off. Yeah, so we will provide freely available resources, ASR, base technologies such as ASR, TTS, forced alignment, but also data sets in time. The data sets right now, speech is difficult to share, as you might have noticed, if you want to do it legally and properly in Sweden. So we're working on that as well. I think we're finding a break with the sharing of speech, which is nice. So if you want to talk about speech infrastructures, then talk to me afterwards. This is what I'm going to talk about. I'll start by trying to provoke you in two different ways. The second way, I think, is not going to be very provocative. The first one is directly aimed at provoking Magnus, but he already knows what I'm going to say, so he's probably the only one who's not going to be provoked by it. Getting some bad. Okay, fine. Then I'm going to talk a little bit about the history of speech science. This is going to be short, don't worry, but it is kind of relevant, I think. It also goes along with the first section a little bit, but it's a little bit less evil and a little bit more constructive, let's say. And then I'm just briefly going to run into current affairs and the topic of speech recognition. This, I could have picked any kind of speech technology topic and said the same things, but since speech recognition or speech-to-text transcription, automatic transcription, is, I think, the thing that most machine learners are comfortable with talking about, then that's a good topic to pick. I'm mainly just going to get into questions of what the point of ASR actually is. right? So that ties back together to the second provocation. You will get it, I think. Let's start. Oh, this is not what I meant. Been a little bit too stressed. Okay, so speech, when we talk about it, I think that a lot of people believe that it is kind of spoken text, that there is text in our heads, and then we kind of realize it by encoding it into speech, and then someone decodes it into text again at the other end. This is a information transmission model that has been really fruitful to explain a lot of things. It doesn't explain human communication at all, though, and it doesn't really explain speech, but it does allow us to get into the signal a lot, to the actual encoding of the signal, which is nice. I think that speech today is consistently treated as if it was writing, just a weird form of writing. This is the way we treat it. In practice, they are really different. Speech and writing are more dissimilar than similar, I would say. That's what I'm going to try to argue about. So this is the provocative bit, I guess. These are some definitions of natural language taken from the web, from different dictionaries. So a language that is the native speech of a people. Native meaning something you learn when you are born, the first language you learn when you're born, right? A language that has developed in the usual way as a method of communication between people, rather than a language that has been created. Or a language that has evolved naturally as a means of communication amongst people. And finally, the nice one then, any language that has evolved naturally, blah, 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 without conscious planning or premeditation. So there are some pieces here that needs to be in there in order for something to be a natural language. One is that we should learn it without premeditation when we're children, right? We should just pick it up. Another is that it shouldn't be designed. It should not have rules that someone has agreed upon in a deliberate manner. It should just sort of evolve. So these are clearly true for speech, spoken language, and they're true for sign language as well. And some would argue that they're true for singing. They're not true for writing at all. Writing is something you learn in school. It has a system, grammar, that is designed by people and written down into books. Before it's written into books, it doesn't exist. It really doesn't. Just read an old book. Spelling is the same thing, right? It's not something that we naturally just fall into. Neither are, of course, the characters we use when we write. None of that. None of that is something that can be called natural language. It's all a convenience system, the system that we agree upon, rule-based. Okay. So some differences, other differences maybe between speech and text or writing. So speech is primal, right? It may be the cradle of language. Perhaps it is singing instead. Perhaps it is signing, but it's one of those. It's not writing. Language did not start off as writing. We know that. Writing is an invention, right? It's a hailed invention, and we know pretty much when it was invented. So speech is really old. We can't really say when it started. Writing, we know pretty much exactly when cuneiform was first found, right? And it's young. Speech sprung out of a communicative need, right? It came because we needed to communicate better, either for reasons of getting laid, or for reasons of running away from dangers, or to find food, but for reasons of communication. Writing probably has its origin in a need to structure data, and more than anything, a need to get persistent data, right? The data that doesn't disappear immediately, that we can actually hand on between generations without having to memorize all of it. It's a great invention, super influential, of course, but different. Speech is tech independent, I would say, but today, of course, it isn't. But it's kind of technology independent, whereas writing is a technology. That's what it is. Speech is transient. It disappears as soon as I've said this. It's just gone, right? Every millisecond of the speech signal just disappears. It's just there, just as I speak. Writing is the opposite. It's persistent. Speech depends on the situation. This has to do with the transience, of course. So the place where I'm saying this, and the group of people listening to me now, decides what I'm saying, and I'm also, that's why I want the cameras, right? I want to see whether you seem like you're falling asleep or whether you look way too angry for me to actually complete the provocation slides. Maybe I should just skip that part and go on with something else. If you're laughing a little bit, then I'm fine, I think, maybe. So this is the way speech works, right? It's produced in collaboration between you and me, even under circumstances like this, when I am the speaker, the designated speaker, and you are the listeners, I'm still using feedback from you. I also use feedback from myself as I hear myself speaking. If I hear that I misspeak, that I mispronounce a word, I go back and correct it, right? So there is an autocorrection thing going on, an error handling thing going on at all times, but it's live, it's real time. In writing, you have the same thing, but you fix everything until you're kind of done, and then you press print, more or less, and that's it. You don't really go back and change text much after that. And it's not done in collaboration with the readers normally. So in writing, you have to put everything in there that is enough to interpret the writing, right? You have to get everything in the words, the context that you have. Okay, you know it's a book in psychology, so a little bit of the context is given by that. You know that it's written by a person with a specific theory in psychology, a little bit is given by that as well, but it's almost textual context that as well, right? And the rest of the context is in the book, it's in the text, it has to be there. And you're supposed to be able to read it if you just know the basics of psychology. So anyone should be able to read it. You have to get a lot of information compressed in there then, and you can't be very versatile. You can't change. If you realize that 50% of my readers aren't really getting this book, you don't go back and change the book. It's set. So that means it takes a lot of more planning to get writing done properly, right? Because you can't rely on fixing the things as you go along. Speech is the opposite. You always rely on fixing things as you go along in a normal conversation, whether you know it or not. I will get to some different types of speech later, but this is a standard, this is speech in a standard conversation I'm talking about. The way speech the way speech evolved, right, in conversation between families or groups. So speech is situation dependent, and it can really only be interpreted in the situation when it was spoken. You need to know something about that. And actually, if it's going to be a proper speech, then it's co-produced, and it's difficult to do any kind of full interpretation post fact, since it should be built online, right, between several people. So unless you're one of the people building, it's not the same thing. That's not really a problem. It's just the way it is. Speech is multimodal. It depends a little bit on what you mean by the weird modality word, which is kind of hard to define. But even speech, if we turn off the cameras and we just use the audio, I would argue that it could still be called multimodal. You have a lot of things in the speech signal that isn't the words. So if you view the string of words as one modality and you view my tone of voice as another, you also have other modalities or other information pieces, like me drawing breath. I don't know how this microphone works now, but I would imagine that it works well enough. And I don't know if you all know this, but human breathing when we speak is clearly audible in normal cases. It's audible to everyone in the room. We just filter it out consciously, so we don't pay attention to it. But the brain picks up on it. So if I end a sentence that could possibly be the end of my speech, so I'm done now, and then I do that, then you know that I wasn't done, right? I'm going to go on. But if I would have ended with instead, you know that I'm done. This is also visible in my posture and things like that. When I'm done, then I sort of fall in a little bit, like you do when you exhale, and I would likely look up at the next speaker as well. So you have eye contact and lots of things. And this is not, you can't really tease this apart easily and say that the breathing gives this signal and the eyes give the other signal. It's more like if we're in a group, we're all talking and I'm listening, I'm sitting like this, and then I want to say something, I'm going to be doing something like this. Right, so I breathe in preparation. I also open my mouth and I put my tongue in a good position to speak, and I erect my back, which is something that kind of happens because because I inhale, and I also catch the eye of the person speaking, so as to say, look, I wanted to speak now. All of this is sort of one big iconic gesture, and it's really difficult to miss, but we don't often think about it. It's just parsed and forgotten, right? It does affect us, though. We can easily do tests with avatars or with fake people and see that this affects people a lot. If you build an avatar that always do the thing when it stops speaking, people have a really hard time actually ever saying something to it, right? It's an easy tests to do, very easy tests. So speech is multimodal regardless of whether you include a visual model or not, a visual mode or not. It's always going to have a lot of more information than what you find in the string of words or phonemes or whatever you want to call it. It's emergent instead of static. I've touched on that already. It's lived by participants, we can say. So it's something we co-produce. That's maybe the same as emergence, that it's being emergent. And I would say that speech is mainly governed by pragmatics. Most of us we have some kind of goal. It might not be explicit and known to us, but we have some kind of goal when we speak. If we're at the coffee machine and we just talk about if the car is running well or not, there is still a goal to that, right? It's still social lubricant. We're still trying to keep in contact with our colleagues or something like that. So that's the goal then. Meaning that understanding is pretty low on the scale of what you're trying to achieve, but pretending to be on the same footing, that's important. That's what you're trying to do. Doesn't really matter if I heard that you had a Ford or a Volvo. That's not the goal of that conversation, right? If I'm at a car dealer and I'm trying to buy a Ford or a Volvo, then suddenly that becomes really important, if the dealer hears me right or not. So I would say that speech is governed by pragmatics. It's always governed by what you want to do, what you're trying to do when you're speaking to someone. Whereas writing, yeah, of course, you have to know who your reader is and things like that. There is a message being sent. So one way or another, you have some intention with your writing, but it's also governed by grammar in a much stronger sense than speech is, right? So if you break all kind of grammatical rules in writing, you get into a lot of problems. That doesn't really happen in speech. You can speak very strangely and not get in a lot of trouble in any case. If you're disliked by people, then they will pick on every little weird thing you say. But if you're liked, you'll be fine. It's not the actual wording, it's whether people like you or not. All right. So from this, one thing that is a take-home message from that slide is that a string of words is a really poor representation of the meaning or intent of something that is spoken. It really is. You can test this yourselves by just reading a couple of excerpts from transcripts without knowing what it is you're reading, and you won't get it. If these are literal transcripts where everything is written down, it'll be worse. Often transcripts are actually fixed, so you remove a lot of the speech features, so just to make it sort of readable text, which is what happens, of course, when you subtitle. Right? Subtitles are not transcripts of what's being said, except maybe in YouTube, and that's very often not legible for that very reason. Okay, let's see. Let me catch my breath. Right, so I should touch on new media and things, because that is kind of interesting, and there is a lot of science and research to be done there as well. So the amount of interactive text that we see is steadily increasing. It has been since, I don't know, the dawn of the text message on the phone, or maybe I had a different life before I became a scientist. I was an international tradesperson for 10 years or so, and we used telexes to communicate with Czechoslovakia. It was Czechoslovakia then. And we figured out that on modern telexes, they're actually duplex. Both directions are open at the same time, but no one ever used them like that. But if you actually typed in both directions, that would work. So you could use them as chat things. So we did that, or I and one secretary in Prague, at least, had conversations like that, a lot faster than not using that. But of course, there was no there was nothing to fix the turn taking. So if you happen to type at the same time, then the typing would actually be mixed every other letter or so, and pretty difficult to read. So it wasn't the best of technologies, but it was chatting. It was interactive and real time. Of course, the talk protocol stems from what, the late 60s, I think. But now chats are really, well, people use them a lot, right? There's a lot of text being produced in interactive situations. It's still kind of unimodal, but emojis help a little bit, and I don't know, maybe all caps and things like that, if that's what you like. I notice myself writing a lot more as when I speak, when I'm in a chat, than when I write an email. I also notice myself that I quite often lowercase everything when I type in a chatty manner, and I use sort of proper writing otherwise. It's more to clear my own mind, I think, than to help the recipient. But I do it at least, and I know that I'm not the only one as well. So there's a lot of text data that is really text, but it's produced in a manner that is pretty similar to how speech is produced. So that's confusing then, for if you want the clear cut things that I just try to present. And of course, we get more and more speech that is produced in a text-like manner, that is either read scripts, which is, it's text, just someone is reading it aloud, like audiobooks or talking books. So you could argue that you've added some things like prosody and stuff, but I think that an audiobook is still closer to text than it is to speech. There is none of this emergent things, right? You're just adding a little bit of drama in the voice, but it's not produced the way that speech is usually produced. So this becomes confusing. And of course, you have podcasts that are also often quite proper. Someone reading a script or something like that, which makes them not so speech-like, from my perspective. So this is confusing, maybe, and we've tried to clear it up for ourselves a little bit by making these distinctions. They will not help in many cases where the situation is much more complicated, but I think they help in a lot of situations, so I like them. So we're making a distinction of the form that was used when the resource or whatever the data you're looking at was actually created, when it was designed, when it was written or spoken, and also at what the format that you're actually studying is. These need not be the same, right? They could be different. So if you're studying text, written materials, and you're studying the writing, then that's easy. You're studying written text. If you're studying, let's say, speech synthesis of talking books, or just talking books, what way should a talking book be read in order for the reader to best appreciate the content, something like that, then you're studying spoken text, right? So it was written as text, but you're studying the spoken form of that text, okay? If you're studying speech proper, so speech and, produced as speech, like my speech now, and you're studying the speech form of it, not a transcript, then that would be spoken speech, easy again. And if you're doing what is commonly done in modeling, studying the transcript of speech instead, then, well, that's written speech then. So it started out as speech, but it is now writing. I find that if I make these distinctions when I talk about these things and when I write about them, the life becomes a lot easier. So it's a suggestion. Okay, so the other slightly provocative thing, I don't think this is provocative at all, actually. I'm just trying to be special. We can view speech, I think, in many perspectives as researchers, but these two I'm quite familiar with, so I'll talk about them. For machine learning today, I think that speech isn't much, really. What it is it's a hard task or a challenge for machine learning algorithms, right? It's a step up from text modeling, let's say, or it's something new to apply video processing techniques on. That's really what has happened a lot. And as such, I mean, that's fine. If you study machine learning algorithms, which is an honorable trade, of course, and it is science, you need applications, you need tasks to try it on, to see whether your algorithm is generic enough or whether it needs tweaking, right? And speech tasks are good for this. But I think that there is often a confusion here that machine learners who use speech tasks to test their algorithms are speech scientists. They're not. They're machine learners testing their algorithms. If you want to understand speech or build speech applications, that's not where you need to be, really. I think this is one of the main reasons that a lot of speech applications are truly horrible. Because there is no application for a thing that just transcribes speech 0.1 promille better than another thing that just transcribes speech. There is no application for some random transcription of speech. There is no need for that. Unless you know what you want to do with the transcription, you have nothing. Right? And if you know what you want to do with the transcription, I'll get back to that, then you need other evaluations than this. Word error rate is never going to take you anywhere. It really isn't. It is if you want to evolve the algorithms or compare algorithms, but it's not going to take you anywhere into speech science. Okay. And so the applications that are discussed when machine learners need a demo or a use case are often from a speech science perspective quite bizarre. They're not really helpful. They're often of a technology readiness level that is super high. So, and often bad technology of a high readiness level, which is something that, it's not that useful and it's not really science. So the algorithm research is still science, but the applications are just not interesting at all, I think. From a speech-centric research perspective, from a speech perspective, let's say, it's kind of the other way around. The main fundamental research question is, how does speech work? How does people work? Do people work when they engage in speaking? What is it for? What makes it tick? What assistive technologies might help it or might ruin it or whatever. Machine learning then, from that perspective, is not science. From that perspective, it's just one of many tools in the tool set of a speech scientist. Machine learning is used to help out with basic annotation so that you can get that done a little bit faster, often with a human in the loop, though, because the results are a little bit too bizarre to work for science, but you can start there and fix it with a person. They're used for analysis. I would like to spend a lot of time talking about analysis by synthesis, but I will do that on a later occasion. It's also used for hypothesis testing, right? If you have an idea that something is going to sound one way because of something, you build a model of it, you generate, and you see if it sounds like that. Now you can do the same kind of thing with machine learning. If you feed in the data that you think should be sufficient to resolve some issue, some information bit, well, it should do that. Otherwise, you're probably wrong, or the machine learning algorithm is really off. But it's a way of doing things like that. So the speech community, I think, happily absorbs machine learning solutions and use them, but they're not really being developed by the speech community. Most of it. There are, of course, people who are doing the crossover and know both sides here, but that's uncommon. That's not the commonplace thing. I'm going to add this. I saw Anuranta give a presentation with this slide in it just a few days ago, so I can't help myself. I thought it was funny. So this is about statistic language modeling versus grammars then. And it's Arne's words, not mine. But so his claim is that grammars are experiencing trouble right now because you have to have a PhD in linguistics in order to understand language enough to use them. You need 5 years of work to actually apply them, to understand the grammars and to apply them. They won't cover much. They're kind of brittle and not very robust, and they're perceived as obsolete. Whereas if you just use statistics, you need a bachelor in computer science. You need 5 weeks of waiting, not work, note, you get a wide, broad coverage, it's robust, and it's called state of the art. Now, this is on talking about his own topic, which is the grammar side of things. I'm gonna get back to this at the end of the talk. I really don't know what artificial intelligence is, so I feel queasy about talking about it. I used to be sort of, I understood a little bit of what Minsky said, I think. And I'm not sure that I agreed with any of it, but I thought I used to understand a little bit of what artificial intelligence might have meant in the 50s and 60s when they actually debated it. Now I have no clue. I really don't know. But I think that from what I gather from WASP's homepage, main page, and things like that, I imagine that if you want to call something artificial intelligence, it probably should account for both the speech perspective of things and the machine learning perspective of things along the lines that I just outlined. I don't think it's okay to just do one of them if you're going to call yourself artificial intelligence. I think that's just off. If you do that, then you're speech or machine learning, and you've been in existence for 100 years or so. So I think you should mix them, and more things than that, I guess. All right, done with being provocative. Now I'm going to talk about a few fun things. How am I on time? I'm okay-ish. So I just try to bash text for being new and say that speech is primary and has existed forever. Now, if we go to the quantifiable study of the two topics, text and speech, it looks different, right? Because there was we could do armchair studies of speech for forever, of course, since the dawn of speech. But if you want to quantify anything, that just didn't work. There wasn't really any way of doing that until 1878 or something like that, when Edison, I guess, stole the patent. Isn't that what he did most of the time? I've read something. Whether he actually came up with this himself or whether he just refined it, I really would suggest that you read Edison's patent and also the few texts. He wrote a few texts afterwards explaining how the recording machine could be used for different things. And he kind of pinpointed everything we do with recorders today in a list of 10 things that will happen in the future. He did that in 1881, I think. It looks modern now. Well, the language doesn't, but the list is. It's really nice. So before this, we just couldn't quantify speech at all, right? So there is no speech science in the sense that I'm talking about it before the 1880s. Text, of course, we've been able to count things and look at static text for much longer. This is Gunnar Fant. He's a founder of the lab where I'm working. He's also one of the founders, I would say, of modern speech science. And this may sound horrible in your ears now. I don't know anything about the levels, so be prepared.
How are you? I love you.
Can you hear what that said? Yeah, did you hear the words?
Yes.
So that's Uwe Et. It's either the first speech synthesizer in the world or the second. MIT claims the honor as well, but it doesn't really matter much since Fant was at MIT the year before he did this. So it's kind of the same technology in any case. It just appeared in two places where Fant and Halle and others were in both places. So it doesn't matter, but it's a very early speech synthesis system. And apart from making the claim that my lab was really early, it also goes to show that okay, thanks, good. It also goes to serves as an illustration of speech science. So Gunnar Fant considered himself a phonetician. He may be the father of modern phonetics, one of the three at least. He came to to KTH because he needed funds, right? And he was good at raising funds. So, and the funds were within telephony. So the big players here were at MIT, funded by AT&T, and at KTH, funded by first the Americans really, and then the Russians. Gunnar didn't really play politics; he just wanted research funding. The reason why he wanted to do this synthesis was not that he wanted to do spoken dialogue systems. He had no intention of doing that at all when he did this. He had this theory that the vowel quality, whether you produce an or e or something like that, could be described in terms of two formants and nothing else. That would be enough to say whether it's an e or an a or whatever. And in order to test that theory, he built a thing that produced sounds that had, where you could control these two formants. And this is what we were seeing here. And he then changed them to the positions where he thought they should be. And then he listened and said, so does this sound like the proper vowels that I'm aiming for? And it did. So this thing says, how are you? I love you. It actually doesn't. It says, how are you? I love you. It can't do any consonants at all. It just does vowels. English is really good because you can find pretty long sentences with not a single consonant in them. So he could fake language, but it was really just after verifying a hypothesis about how vowels work in perception and production. Right? Then this, of course, became the foundation for proper speech synthesis for the next 40 years or so, 30 at least. But this is kind of typical for speech science, though, the double utility. You have the research area, which is how does speech work, and you have the other research area, what can we do with artificial speech? Can we do things with that? Sorry, I've done that. I think I skipped a slide. No, I didn't. All right. This is going to be fast, at least. This is really just to show you that speech science is a big area. This is just speech, music, and hearing. This PhD students or PhDs from speech, music, and hearing since the 50s and up until now. I don't know how many we are now, but pretty much every single one who graduated from our lab is working with speech science today. It's almost 100% uptake. People stay in the area and they get jobs. The Amazon dude that is on top there is the Amazon lead for ASR, which is a big position, and several of these other positions are similar. So it's good to be in a lab that has some history for these reasons, of course, because the networking thing gets easier. But this also shows there are a couple of labs like this in the world, and the people that run this in the industry are normally speech scientists. That's where they come from. I'm not going to go through this in detail at all. Just want to say that speech science is highly interdisciplinary. So in these and in many more disciplines, you will find people that are mainly interested in speech, people that believe that speech is what they're actually studying. The other way around is not true, of course. Not all of these people study only speech, but you will find scholars in these disciplines that study speech more than anything else. And this is the 31st, I think, the 31st of the 120 or so externally funded research projects that we've found. We're doing we're doing a collection for the European language grid for Swedish speech tech projects, and we've found 110 for the past 10 years just by scouring a couple of databases. These are all externally funded, and if you can at all see the writing, you will see that they target very different things, but they all have speech at their core. Oh, these are 30. The full list is 110 or something for 10 years. All right. This should all come at once. I'm sorry about that. All right, so a little bit about applications, and then I'll just do the finishing slides. So speech has been a kind of a big deal for applications in hype since, I guess it's actually since the 60s, but these Bill Gates quotes are funny because they're from the 90s and the notes, and I thought they were really funny when I showed this slide the first time in something like 2005, because the speech technology area is one of these areas where people have always said this is going to work within 5 years, and they've said that since 65. You just keep pushing it in front of yourself, right? And when I used this slide in 2005, it was the same thing. It still didn't work, right? And this was meant to be funny, that Bill thought it would work in 10 years and then he just postponed it by 10 years. And the idea was that he's going to postpone it again in 2010 for another 10 years. That didn't really happen, right? So Apple released Siri and pulled in billions of hours of speech and kind of solved a lot of things. And at the same time, machine learning just came up with some brilliant ideas of how to produce speech as if it were pictures, really. Strange way of doing it, but it works. So these curves show how quickly the smartphone reached 50% of American households. So that's the fastest technology to reach 50% penetration up until then. And then the freaking smart speaker. I have one because I'm a speech scientist. I'm curious, right? But I don't see the use of it if you're not. If you don't think it's a fun toy, then I don't know what you need it for. I really don't. And I use it for a lot of things, but I mean, I have a vested interest, right? In any case, 50% market penetration in no time. Amazing. So there's money in speech science now. And weirdly, there's money in bad speech science that doesn't really work, that doesn't really provide any value. So that's the difference. And Bill Gates no longer have to postpone this is going to make us money in 10 years anymore. It is making people a lot of money right now. There is a lot of real values that are within reach for speech applications. So anything that has to do with accessibility of text or of images, of course, for anyone who either cannot read for some reason, cognitive abilities, or if you're blind or something like that. But it also has a lot of accessibility benefits if you can't use your hands, if your eyes are otherwise occupied, things like that. It's super useful for inclusion and democracy things for the same reason. If you can read out loud texts for let's say the 50% of the world's languages that doesn't have a written language at all, for example, then you could make a Wikipedia that actually provided information for people who can't read or write, either because of they haven't learned or because they mainly communicate in a language where writing just isn't a thing, which is kind of a big deal. Sustainability is something now, I think. We speech scientists have always tried to claim that speech is good for sustainability. I think that this has been proven now. I guess we all kind of hate these Skype meetings, the Zoom meetings, but I think most of us must also have noticed that we don't have to travel, right? This is the first year in my lifetime that I do not fly once in a year. And I'm kind of pleased with that. I can't say that I'm too displeased. I'm not going to pick up traveling as I did before again. That's just not going to happen. And there's a lot of supporting technologies that we could do for this kind of meeting that would make them much better. And we kind of know how to do that. The science is already there. It's just implementations. And there is a load of health things you can do with speech, everything from coaches to early diagnosis and things like that. There are some market values that are under exploited now, I think. Entertainment is the main one. That there is a gap with the gaming industry's short turnover times for new models or new versions, and the time it takes to actually implement a speech solution. So it's difficult to get speech into games for that reason, but it's kind of obvious that good speech would help many games, I think. A big deal but difficult is collaborative manufacturing. So I'll show you what I mean. 1, 2, 3, heave. Right? If you want to lift something together with a robot, the way people would do that is by actually counting themselves in or saying stop, 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 wait a little. That's faster and more precise than just relying on sensors. If you're two different robots or a person in a robot, so that you're not really built to work together to begin with. Okay. Yes. So some issues on how we model speech, and I'm gonna use speech recognition. ASR is it's the word that is used mostly in speech science, automatic speech recognition. It's a misnomer because it kind of talks about recognizing something as being speech, right? Rather than recognizing the contents of it. But it's not as bad a misnomer as voice recognition, which is used in science and means recognizing someone's voice. So Magnus's voice or my voice. This is used a lot in the industry now, which is terribly confusing for everyone, I think. I kind of prefer speech to text now, because it works with laymen and with scientists. So I think that's kind of okay. It also translates well to many languages. But apparently I wrote the ASR here out of habit. So you would have read reports, I think, or at least headlines saying that ASR now beats people. And the first thing one perhaps asks oneself then is, how can you do that? I mean, a person gets 100% right, if transcribing something, if they do it properly. No, that's not true. People, for one thing, don't do things properly for longer periods of time, but you know that. So annotators will fail. They will actually write the wrong word or things like that. They will miss things. But the more important reason why people don't get 100% is that there isn't really 100%, right? The reductions in speech, the changes, the pulling words together or just skipping words, is just way too much for there to be one correct answer. So if you ask 3 people to transcribe the broadcast news corpus, for example, which is newsreaders, right? These are people that are trained speakers. They don't, and they speak professionally when they do this. You will get an inter-annotator agreement between these people of 98% or 97 or something like that, no more. So 3 out of 100 words they don't agree on, not all 3 of them at least. If you get machines to take part in this, they will be more consistent than the people. They will make the same errors over and over again, of course. So they will exhibit a more consistent behavior, and they will get the same inter-annotator agreement as people. So if you take together that they are more consistent and that they don't vary more, or they're not more off from any of the human transcribers than other people, well, you get a system that is better than people. So that's perfectly doable. The top line isn't 100%. The top line is 97 or something. So consistency becomes the measure. And yeah, they are better for forced alignment, which is transcription. When you have the transcription, you just want to know where the language sounds are. So where's the in fur, right? Where does it start? Where does it end? It's a notoriously difficult and slow process for people to do that, and we're not very consistent at all because it's difficult. The sounds sort of blend together. Machines will do a much more consistent job out of this. So today we use machines for this always, not for money's sake, but because the results are much more reliable. Whether they're right or not doesn't really become an issue here, right? The question is, are they done the same way all the way through? Because it's it's something that you can get from the data you're training on, right, without going outside of the data. But it really doesn't work for speech science at all. There's almost no correlation between word error rates and the ability to perform some kind of task or to the ability to do some kind of research. You need to know what types of errors you're getting, right, and what the task is. So for quite a few tasks, something like getting 70% of the words right is okay. And getting 72% of the words right doesn't really matter. It doesn't help much. It's pretty much the same. Tasks like this is, for example, assisted transcription, right? So you have a machine that provides a basic transcription that you know to be wrong, and then you have someone correcting it so that it'll be a little bit faster than typing it all from scratch. Of course, 90% is better than 70, but all the way down to 70, it helps to have a system like this. When you drop under 70 towards 50, something there, it's actually much faster to just type it from scratch, right? But the threshold is lower than what you would expect for many things. You would maybe expect that for a chatbot that doesn't, like I said earlier, that a chatbot doesn't really need to know what it's talking about much, not if it's just there to socialize, to do coffee machine mingle speak. That's not entirely true though. Chatbots often pick up on content words, and then they try to bounce them back to the person they're speaking to. And if you miss a content word and happen to pick up something that is controversial or illegal, and you bounce that back, it's enough that you miss one word out of 100, and you will have created a really bad coffee table conversation. It's fast, right? So for that kind of knowledge nest systems, I would say that actually it's a little bit the opposite. You need to take care to at least vet the speech recognitions, or you can get a really bad system. It's the other way around if you have a system where you really want to do information transfer and nothing else. So I want to know when the next train to Uppsala is. Now, in systems like this, if you're only good at building them, you can have error handling that is kind of human. So you can just do rapid feedback whenever you feel a little bit uncertain if you heard right. Was it Uppsala or was it Gävle? Or you don't even have to do the annoying, did you say Uppsala? It's a lot better to say, okay, to Uppsala, and you get people that will say, no, Gävle. And that's fine if you can deal with this, right? This is how people do it. This is why we don't spend super much energy on explaining everything too much. But we rather just try it out. And if it doesn't work, we will become a little bit more explicit because it didn't work. If I think that you can't hear me speaking now, I will suddenly speak a little bit louder and I will speak a little bit clearer, right? So we are adaptive like that. Systems can do that too, especially if they are information collecting or transferring systems, because you can have a feedback loop and they can try to improve, or they can try to become more slow and explicit whenever things are bad, and they can be more rapid and implicit when things are good. So for systems like that, ASR doesn't have to be fantastic. Whereas for dumb systems, I think it's actually more important that the ASR is a bit sus. The smarter the system, the more you can sort of save face by just doing standard conversation skills. Right. You have to look at the consequence of error as well. There's still today, one of the first projects that I encountered when I started in the 90s with this was, it was a toy domain. It wasn't real, but the domain was air traffic control, right? So let's take a domain where one mistake will kill at least 350 people and try our new technology on that. That's a bad choice, right? And now people are getting back to air traffic control saying that, look, we should do this again. Now, of course, the idea is that machines can be better and more reliable than people actually, and you could eliminate the human error. I still get queasy when it's things where small mistakes will really kill a lot of people. I think there should probably be other domains where the consequence of error isn't as dark. So if you wanted to get a feedback loop from ASR, from speech recognition that actually is supposed to do something in the world, you would want to know whether it can point out the objects in the room that you're talking about, right? You would want to know whether it can understand that when I say tomorrow, now, I mean on Thursday, not on Friday or Monday. You would want to know whether it understands that if it contributes, it actually changes what I say. So you would want it to not just be ASR, you would want it to nod. You would want it to ask clarification questions, and you would want to see whether it can quickly understand or do whatever it's expected to do by using these techniques. And I realize that this is really difficult to set up as a feedback loop. Otherwise, people would have done it. Speech scientists would have done it. We're trying, we're working on it. But the fact that it's difficult doesn't mean that it's the wrong way to go. It isn't. It's the right way to go. And it's, I think, the only way that we'll actually get speech science that is better than it is today, and speech applications that actually draw on the true usefulness of speech, which is vast, which is tremendous, but it's not really being used much now. So we're missing models that are multimodal, that can handle several channels at the same time. We're missing models that take care of the situation. The situation in my vocabulary here is the same thing as context in linguistics, only it's not just words and background knowledge, it's the room and the time as well, and the objects in the room. But it should be possible to model it in a similar way as we model the linguistic background. I can't see that would be impossible at all. But it is multidimensional and stuff, so difficult perhaps. We need multi-speaker models. We need models that understand that if someone finishes my sentence for me and then I continue, then that doesn't make the string of words suddenly really strange, right? So if I say my name is Jens and Magnus says Edlund, and I say and I live in Solna, there shouldn't be a peak there saying this is the strangest thing anyone has ever said. It should be as normal as if I said the whole thing myself. So we need to figure out a way of modeling several streams at the same time. And this doesn't happen much in text. It does happen all the time in speech. So this is difficult as well, but it's something that we need to solve. Yeah, we obviously need both evaluation and reward functions that aren't based in getting the right word, because it doesn't help at all to get the right word. It doesn't even begin to help. And I think we need knowledge about how speech actually works. And I'm going to back down on what Magnus said here. I don't feel that I really am an expert at this. It's a very open subject. I don't know that anyone is an expert, but I do think that maybe honors PhD in 5 years of work is a good starting point. Yeah, thank you.
Thanks, Jens. I think that was a really great presentation. I didn't think it was too provocative at all.
Okay, I will try harder next time.
Yeah, I actually agree with everything that you said, and since I don't really know anything about speech technology, but your presentation makes me want to become a speech technologist. So maybe I should switch academic careers after this.